Hi, in this session I am going to discuss what are different types of operators present in C++ programming language. So let's get started. So the different types of operators which are there in the C++ programming language. First, what is an operator? Operator is a symbol that tells the compiler to perform specific mathematical or logical manipulations. There are different types of operators: arithmetic operators, relational operators, logical operators, bitwise operators, assignment operators, and the operators which is not going to fall under these categories are going to be called as miscellaneous operators. First, arithmetic operators. In arithmetic operators, we have plus, minus, into, divided by, modulus, increment, and this decrement. Okay, if I am going to assume A is holding 20 and B is holding 30, then what's the expected result I am going to take? A plus B is going to give 50 because A is holding 20 and B is holding 30. It gives 50 as the result. A minus B, it gives minus 10. A into B, it is going to give 600. B by A. B is divided by A and it is going to give the result 1. Because you are expected what? 30 by 20. 1.5. Okay, 1.5. If you are going to make it as floating, okay, let's do with the program otherwise. So, int A comma B. A is holding 30 and B is holding 20. Int C equal to A plus B. C of C, D and DL. End of the line. So, what is the expected value? The expected value is 30 plus 20. That's nothing but 50. If I am going to make it minus, then the expected value is 10. If I am going to make it A by B, then I am going to get 1, because see, the integer values are careful to store only the integer value, not the floating value. So if you want to see current 5, then you are going to make the data type as a float. So the holding value, the result is going to be C equal to A by B. Let's run this program. 30 by 20 is going to give 1.5. If you are going to make it the integer type A, B and C, then the 0.5 is going to be neglected. Okay, if you want to consider after decimal also, then you are going to make the data as a float. Then if I am going to multiply this one, then I am going to get 30 into 20. That result is going to be 600. Okay, now increment and decrement operators. Increment and decrement is nothing but int I equal to some 10. Okay, I equal to I plus plus. I am going to see what the value of I is. Then I am going to get 10. I am going to get I equal to 10 and I plus plus. So I plus plus is nothing but it's going to be same as I equal to I plus 1. So 10 plus 1, the resultant is going to be 11. If I am going to use the decrement operator, I minus minus. Now what I is holding? I equal to I minus 1. There is nothing but 10 minus 1. You will be able to see 9. Okay, this is called as increment and decrement operators. This comes under arithmetic operators. Now, if I am going to use the modulus operator, A is holding 30 and B is holding 20 and the modulus C equal to A modulus B. Okay, A modulus B, 30 modulus 20. Now what the C is holding? It is going to give the remainder 30 by 20. What's the remainder? 10. This is all about the arithmetic operators. Then, what is relational operators? It is going to give the relation between two variables. Like if A is holding 20 and B is holding 30, then it is going to compare the both values. If you are going to use double equal to, A double equal to B. A is holding 20 and B is holding 30. Now, if you are using A double equal to B, it is going to give false because 20 is not equal to 30. Okay, 20 is not equal to 30, so it is going to give false condition. Now check, 20 not equal to 30. Yeah, this is true. Now 20 greater than B, it's not true. 20 less than 30, it is true. 20 is greater than or equal to 30, it's not true. 20 less than or equal to 30, it's true. Okay. You can do as before the same program. You can use this particular operators. You can assign A equal to 20 and B equal to 30 and you will be getting these particular conditions. Okay. Now, logical operators. Logical operators is going to tell if it is going to check the relation between both. Okay. Double ampersand. That's nothing but A double ampersand B. If A condition satisfies and also B condition satisfies, okay, then it is going to give true condition. Assume that A is holding 1 and B is holding 0. A is holding 1, B is holding 0. Okay, one condition is true, other condition is false. The resultant is going to be false. Okay, this symbol is nothing but OR operator. If A is holding 1 and B is holding 0, one logical OR operator 0. Okay, one condition is true, other condition is false. That's going to be resultant is going to be true. If either of the conditions satisfies, then it is going to be true. Okay, not, this is nothing but exclamatory mark is nothing but not. A double ampersand B is true. Okay, if both conditions satisfies, then only it is going to give true condition. A is holding 1 and B is holding 0. Okay, the condition fails and it is reverse, not operator, so it is going to be true. Okay, later on I will be discussing the logical operators, then you will understand better. Bitwise operators. Now let us assume PQ. P is taking 0, Q is taking 0. 0, 1, 1, 1, 1, 0. Okay, now ampersand is nothing but AND operation. P and Q. P into Q. The resultant is going to be, if both conditions are true, then only it is true. In either of the conditions, it is going to be false. If both conditions are true, then only I am going to get true condition. If either of this is going to fail, then that particular result is going to be fail. That's nothing but 0. P or Q. P or Q, that's nothing but P plus Q. If either of this is going to satisfy, the condition is going to be true. Okay, only when the both conditions are going to fail, at that time it is going to be 0. Now, P caret Q, P XOR Q, that's nothing but P Q bar plus P bar Q. The resultant is nothing but XOR gate. Okay. Now when both are zeros, at that time it is going to give 0, and when both are 1, at that time it is going to be 0. If either of these conditions satisfies, if one is true, one is false, the resultant is going to be true. If this particular condition is P is true and Q is false, then it is going to give the resultant as 1. Okay. Now see, if I am going to perform the particular integer values, if A is holding 60 and B is holding 13, first the particular decimal value is going to convert into binary value. 60, binary equivalent is 00111100. B is equal to 13 in decimal format. If I am going to convert in binary format, it is going to be 00001101. So if I am going to perform by using bitwise operators, if I am going to tell A and B, let's execute this program. Okay, if A equal to 60 b equal to 30.